Okay, so today we're talking about variable and expressions. So today we're going to write expressions for algebraic expressions, and we're going to write algebraic expressions for verbal expressions. So we start with a problem. It says Cassie and her friends are at a baseball game. The stadium is running a promotion where hot dogs are 10 cents each. Suppose D represents the number of hot dogs Cassie and her friends eat. Then 0.10 times D represents the cost of hot dogs they eat. So we are to write variable expressions. The algebraic expression consists of sums and or products of numbers and variables. In the algebraic expression 0.10D, the letter D is called a variable. In algebra, variables are symbols used to represent unspecified numbers or values. Any letter may be used as a variable. So as in the problem I just read, the D would be the variable, okay? Or in some of these other examples, 2x plus 4. The x would be the variable. Or for example, the 3 plus z over 6. The z would be the answer. So it just depends on, it's a letter, it's the variable, okay? All right, a term. A term of an expression may be a number, a variable, or a product or quotient of numbers or variables. Remember, product would be a multiplication problem, and a quotient would be a division problem. For example, 0.10D, 2x, and 4 are each terms. So if we look here, 2x would be a term, and it would be called the variable term because it has a variable with it. 4 would be a term, and it would be called a constant term because it has no variable. Okay. In multiplication expression, the quantities being multiplied are factors, and the result is the product. A raised dot or set of parentheses are often used to indicate a product. Here are several ways to represent the product of x and y. So each one of these ways I could write to say x times y. I could write it in any of those situations, okay? And each one of these would be a factor. So the x would be a factor, the y would be a factor. The result, when I multiply x and y together, that would be the product. All right, an expression like x to the nth power is called a power. The word power can also refer to the exponent. Don't forget, the exponent indicates the number of times the base is used as a factor. In this case, like if you have x to the nth power, the base is x and the exponent is n. For example, if I had 5 squared, or 5 to the second power, my base is 5 and my exponent is 2. Okay? And also, don't forget that if I have a number like 6, it's to be understood that there is an exponent of 1 that goes with it. Okay? All right. So an example, write a verbal expression for each algebraic expression. 6n squared. So I would write out in words the product of 6 and n squared. Okay? It's the product, and that's telling me that it's a multiplication problem. And then I have 6 and n squared. That's the two terms that will be multiplied together. One way that I could do the next one would be n cubed minus 12m. So I could say the difference, that tells me it's a subtraction problem, of n cubed and 12 times m. And I already said it's the difference, so it's a subtraction problem. So I could say the difference of n cubed and 12 times m. Okay? All right. Now, this is the part of the video where you would pause it, work on the notes sheet. There is some problems, these problems you see on the screen, that you need to work. So pause the tape or pause the video, work the problems, and then come back and see how you did. Okay? All right, welcome back. Hopefully you got these right. Let's take a look. So we are to write a verbal expression for each one of these, okay? So in the first one, we have W minus 1. We could say 1 less than W, okay? So that's one way that we could write it. You could also probably just do W minus 1, or the difference of W and 1, okay? Number 2, 1/3, we could do 1/3 the cube of A. That's one way you could do it, 1/3 the cube of A. Or you could do the product of 1/3 and A cubed, okay? Number 3, I could do 6 times K, or I could say 6 times the cube of K divided by 5. So 6 times the cube of K divided by 5. I could do that. I could say the quotient of 6 times K cubed and 5 would work also, okay? Number 4. That one would be, let's see, we could say 4 times the sum of the square of n and 1. So 4 times the sum of the square of n and 1. Okay? So that would work. And again, there's more than one way to do these. It's not always just one way. Okay? But you have to be able to read that and be able to figure out what the problem is from what you write. All right. So let's see. Next, we're talking about writing algebraic expressions. So I gave you a little box here. Addition, you're going to look for words like more than, sum, plus, increased by, added to. Subtraction, you're going to look for less than, subtracted from, difference, decreased by, minus. Multiplication, you're going to look for things like product of, multiplied by, times, just the word of. And division, you're looking for quotient of or divided by. Okay, those are some examples. So let's take a look. If they tell me that for more than a number, I know that more than is going to be addition, and I know that a number would be a variable. I could just n. So 4 plus n would be my algebraic expression, and that's all I would have to write. Okay? B, the difference of a number squared and 8. So difference tells us that we're going to have a subtraction problem. So the difference of a number squared, so that's where I would have n squared and 8. So n squared minus 8 would be my algebraic expression. Okay? All right. Got a couple more examples. So I have 10 less than the product of 7 and f. So we have to break this down. We have 10 less than. Less than is going to be a subtraction. And remember, when it says less than, it means to move it to the back, okay, of the problem. Now, product means a multiplication of 7 and f. So I could say 7 times f, or 7f minus 10. And that would be my algebraic expression, okay? So it's 10 less than, so it's 10 less than the answer of 7 times f. All right. So variables can represent quantities that are known and quantities that are unknown. They can also be used in formulas, expressions, and equations. So I have a word problem here, It says Mr. Martinez orders 250 keychains printed with his athletic team's logo and 500 pencils printed with their web address. Write an algebraic expression that represents the cost of the order. Now we know that we could set K to the cost of each keychain and P to the cost of each pencil. And I know I have 250 keychains and I have 500 pencils. So to get the total price, I'm going to add what I spend on both of those together. So I could say 250 times K plus 500 times the price of pencils. And this is the algebraic expression I would need. 250K plus 500P. And that would give me my total cost if I knew how much they both cost. Okay? All right. So again, this is the time that you would pause the video, work on the practice examples that are in your notes, and then come back on the video and see how you did. All right. All right, welcome back. So we have write an algebraic expression for each verbal expression. A number decreased by 8. Okay? So I have a number decreased by 8. I could say n minus 8. And that would be my algebraic expression. Number 2, a number squared. I could just say n squared. That would be a number squared. Number 3, a number divided by 6. I could say a number divided by 6 is n over 6, or a number divided by 6. Either way would work. All right. Number 4, 3 less than 5 times a number. Remember, 3 less than goes on the back, so it would be 5 times a number minus 3, or 5n minus 3. Okay? All right. Then we have twice the sum of 15 and a number. Well, twice means 2 times. The sum means I'm going to have an addition problem. 15 and a number. So it would be 2 times 15 plus n. Okay? So in other words, 15 plus n I would have to solve and then multiply it times 2. And then the last one, 30 increased by 3 times the square of a number. Okay? So 30 increased means plus by 3 times a square of a number. So 30 plus 3n squared would be the answer. All right. That's the assignment. Go ahead and complete it, and then submit it when you're done. Thank you, and have a wonderful day.